Welcome to Insane Ambition, a business and tech show breaking down lessons and playbooks from the world's most ambitious founders, investors, researchers, and changemakers. So, James, welcome to the podcast.
Thank you.
It's awesome to have you on. You're the CTO of the Bionics Institute. Let's delve a little bit deep into what the Bionics Institute actually is.
We're an independent medical research institute. We were formerly the Bionics Institute. We like to claim we're the home of the cochlear implant, what cochlear developed. We no longer have any official ties with Cochlear Limited. We'd love to in terms of the share price. That'd be kind of handy. But we are not. We're independent. Our mission really is the mission I tell my mum, because that's probably the easier one to explain, is if we can stimulate or record something somewhere and help someone, that's what we want to do. So we do a lot of late-stage preclinical work, early-stage clinical prototype development, take good ideas from other institutes, universities, and match them with clinical problems, increase their probability of success, and then hopefully spin it out and let industry take over in terms of turning into a device that's actually going to help someone.
So did you say it was a private institute?
We're an independent medical research institute, not for profit, like any other. So, we're the very small baby brother of WeHi, Peter Mac, those kind of ones. We're about 70 headcount at the moment in terms of our numbers. We're very much translational focused in terms of we don't do basic research. We only do translational focused research. As I said, it's all about good ideas married to problems that then get kind of turned into solutions that hopefully someone can commercialise and deploy.
Absolutely. So you're the CTO, the technology person. What does that entail? What does your day-to-day life look like?
Yeah, so I've been at the Institute for 20 years now, almost. We got a new CEO about 7 years ago now, Robert Klipax. When he first started, he branded me the research director of the Institute, and about 3 years ago, he rebranded me as CTO. And I must admit, I went to the office and said, "What does that actually mean? Is there a pay rise involved with that?" And he's going, "No extra money."
It's like, actually, you signed the dotted line, so we just call you whatever we want now.
He said the main reason was because it meshes better with industry standards in terms of what my role was. So my role is basically oversight of all the research that happens at the Institute. So Robert, as a CEO, is very focused on commercialisation, very outward focused, raising money, those kind of things. My job is to make sure the research we're doing is top quality. We have a COO that makes sure that everything runs and the lights stay on, and a CFO to make sure money flows appropriately. So I don't really have a very standard day-to-day in terms of what my day consists of. It can, on a given day, I can be in the lab doing experiments still. They still let me in there sometimes. I do sometimes think they just kind of humour me and then throw me out again and get back to work when I actually leave. But some days we'll be in the lab doing real experiments, recording data, meetings with strategic partners about how to commercialise our next great idea. Obviously lots of staff, mentor and supervision, those kind of things, and then keeping the wheels of the business running from a research perspective. One of the unique things about the Institute is we're the only institute that we're aware of in Australia that's ISO 9001 certified for our whole institute, including our research process. So that also takes up a bit of my time making sure that process runs smoothly.
ISO 9001.
Yeah, it's a quality management thing, which means there's a bit more rigour put around all the research we do. In fact, everything we do from a process perspective. Anyone who works in the device kind of medical device space is aware of 13485, which is the quality management system you need to do device development. ISO 9001 is not that strict. It's kind of the next step back, but is more rigorous than what happens in a standard academic lab.
So is the idea with is it a policy? Is that what it's called?
It's a quality management system.
Quality management system. So the idea of that quality management system, is it because the Institute is more targeted towards translation?
Correct, and it's to put the rigour around what we do from a documentation perspective. So your standard academic lab can do top quality science, but sometimes the documentation around exactly what's gone is maybe not up to scratch. And engineering labs are great for that kind of thing. When I was at uni doing engineering, you'd make cool things in the lab with no paper trail almost whatsoever. You need that paper trail. We don't want to operate at the 13485 level in terms of that paper trail because it is expensive and slow. 9001 lets us operate somewhere in between. So we're producing things that are more usable and therefore more valuable when we go to commercialise what we've been doing.
I just got one thing to say. In terms of maybe anecdotal stories that you may have of a time where it did matter that everything was accurately documented. Do you have any situations that you've been in with lawyers potentially, IP on the line, where you're like, oh, I wish we did this better, or have heard of a story like that?
Look, not personally have I been involved in. Obviously, there's plenty of cases out there in the world about what happens when you don't have a great paper trail of what you've done. For us, it's actually more around, it's really easy to have an N of 1 work. It's really hard to get the N of 10, 12. And to have that good paper around it is really important. So I personally haven't been on the wrong end of ones that have gone wrong. So I'll probably best not talk about things that I've heard rumours around, shall we say.
That's all right. Totally understand.
Sure. There's a reproducibility crisis, I think, in research that...
Particularly biology and psychology as well, to an extent, where the results from papers aren't reproducible. So the thing that's published in a paper, other scientists try and do it, it doesn't work, just for our audience's sake. Why do you think that is? And how do you think, what sort of steps do you think we as researchers and as institutes should take in order to encourage the reproducibility to get back into what should be expected, which is 100%?
Yeah. So firstly, I'd argue the reproducibility probably will never be 100%. Like we all go for, it's the magic p-value of p less than 0.05. It was statistically significant. Does mean there's a 5% of the time it won't reproduce well. Why is this a reproducibility crisis? The short answer is funding and the incentives that researchers have to develop their careers. On the way over here, I was actually listening to a Freakonomics podcast on a not too dissimilar topic. And really what it's, really the essence is to advance your career as a researcher, it's all about publications and grants. Good producing someone else's science doesn't get you the next grant, doesn't get you published in a top tier journal. So there's very little incentive to actually do that. There's also an incentive to publish a lot. And so you maybe do 1 or 2 less replicates than you need to, or you would ideally like to, if you're trying to get through more papers. Obviously, very few people intentionally set out to kind of do that, but often there are pressures around doing that. So the incentives that advance people's careers is a big part of it. The fact that people are always interested in doing new, cutting-edge, interesting things. Not many people get into a research career because they want to be the person who turns the handle and does the 20th or the 50th or the 100th experiment. They want to be the first one to have done something. That's pretty cool. That's pretty exciting. That's what a lot of people get into research for. So almost by definition, no one really wants to run that replication study. And finally is the funding. Who wants to fund that replication study? Government isn't really that interested in doing it. Industry is not really interested in doing it. Philanthropy would rather see their money go somewhere interesting as well. So who's left to fund that replication study?
It's a good point. I feel, as a PhD student myself, I've done experiments that were very costly as well. And so you get really one chance. And the funding you distribute towards the experiment is almost a make or break at some points for a lot of people. Do you think that younger students going into research appreciate how competitive it is?
No, I don't think they can. It really is a long competitive world, and it doesn't stop. I still live and die by grants, even as the CTO. I'm expected to generate most of my salary by competitive grants, and they're hard to get. Funding rates in Australia for the major schemes are often single digits. And that's a lifelong event. It doesn't go away. So you are forever doing that, competing with everyone. In fact, I think PhD is one of those few times where you almost have the less competition that you have to strive with, because we give out far more PhDs than we've got room for academic research for. I don't think that's a bad thing. I think people shouldn't go PhD equals academic research career. It's just another way of learning another skill set that you've described. And I think that's one of the changes of mindsets we have to have, is that's a change we need. The other change I often think about is the fact that we have a kind of a one-way door from academia. You can leave academia and go to industry, but in Australia, it's actually really quite hard to come back again. If you look at things like in the States, it's far easier to go back and forth. I think things like that take some of the pressure off your academic research career, because if you're having a bad run, you go and learn some new skill sets in industry, bring them back with a different mindset back into academia. That's actually when some really lovely things can happen.
Very true. I'm curious, how would you, like if you had ultimate power, realign incentives? Like what sort of changes might you suggest we make as the ruler of, the planet, to the hierarchies, to the system, to the incentives, to make sure that research is good, to make sure that people can come back and forth, and to incentivize innovation?
Ooh, the magic wand. I think really a lot of it is, for me, is it's probably separating some of the research focus that is currently on the big universities in Australia. So a lot of the research money flows into the big 8 universities. Full disclosure, I'm an employee one day a week at the University of Melbourne, so that's not necessarily a bad thing. But actually, perhaps they're not the best place to be doing some of this research, and working out how to do different pockets of research in different spaces, I think is incredibly important. I think the government, or as the uber ruler and distributor of the money, it might actually also be one of those probably very unpopular things about picking some wing areas that we want to focus on rather than trying to support everything. So at the moment in Australia, if you've got a good idea and you want to apply for money, you can. There's almost no research area that's off limits. But perhaps that shouldn't be the case. I think there's room to have a debate around, should there be areas of priorities that we want to focus on, and if you don't feel that area of priority, so be it. Very easily said, and obviously everyone thinks their area should be their priority. And so how that actually is achieved without the supreme ruler who can make that decision, I'm not sure how you do that, but I think that could actually be one of those ways to change that playing field. The other thing is also, I think, open access to data is one of those other things that could actually change things quite dramatically. There are people who are really good at designing experiments, running experiments, who perhaps are weaker at analysing, interpreting. There are people who are really good at analysing, interpreting, who perhaps aren't great experimentalists. But we expect people to be everything. You need teams to do really good research, but we don't have good systems to fund teams. A lot of our money flows to individuals rather than teams of people, because it's very hard to work out who in that team is doing well and who isn't, and therefore who to give the money to. So finding a way to fund teams of people to do good research, I think, is really important. It would make a big difference.
Yeah, absolutely. And what about incentives on ownership of things that are produced in these institutions? I feel, or at least from some stories that I've heard from my supervisor, the industry back in the day was almost the reverse. You had, let's say, a lot of private money coming into the industry, and that private money was driving the innovation. These days, it's almost like offset to the research institutes. They're, responsible for getting their grant money, building the innovation, and then the private industry, the biotech, MedTech, they come in, swoop up the patents, and then the researcher gets left behind.
So I think the researchers can get left behind, but I think also researchers often think that their bit is perhaps more valuable than their bit really is. The classic thing is, as a researcher, you've come up with the idea, you've painted it, you've showed your work, you think that's 95% of the work done. It's probably 5% of the work done, and so educating researchers about that fact that it's a very long journey, it's a very expensive journey depending on the field you're in. In the biotech kind of implantables that I spend a lot of my time in, I can have the best idea and there's probably $100 million to go to get a device out there in the world before you even start selling units to try and recoup some of that investment. So my contribution might be incredibly important, but the dollar value of that contribution is probably pretty small in that big pie. But I also think that there's no reason that those inventors shouldn't be appropriately compensated. So at the Institute, obviously the Institute own all the IP that I generate when I work for them because that's part of my contract signing. But we have a scheme whereby, should any of those inventions ever make money, I get a cut of it, as is only fair. The team also gets a cut of it, which I think is also really important, and the Institute pocket the rest and hopefully spend on the next round of research. So researchers can get compensated for their efforts, but also a lot of researchers aren't actually in it for the money. If I was in a job for the money, I'm in the wrong job, let's be honest. There's lots more money somewhere else. Doesn't mean I'm not happy to take more money. If Robert's listening, I'm always happy to have a pay rise. But yeah, so it's actually about getting that compensation, that incentive right. And what is that incentive? For me, actually being let loose to go to another conference somewhere or do a new experiment I really want to do, that's probably more valued to me than, a possible 2% carry on an invention that might pay back in 50 years, because I probably won't be here in 50 years, if we're honest.
Don't say that.
Who knows what the future entails?
Absolutely.
Immortality.
No, thank you.
I'm curious, you mentioned the cochlear implant, and there's obviously a lot of other things that the Bionics Institute is working on. What are some of your favourite projects that you have worked on in the past? And let's leave out the most recent one for a little bit later.
Yeah. So to be honest, the thing I find the most enjoyable with my research I've discovered is I'm not actually that passionate about the disease we work on. I'm actually always not necessarily that passionate about the technology I'm working on. It took me a long while to work it out. What I really enjoy is working with the people. So I actually really enjoy working with the people who I work with on interesting and challenging problems. So I almost don't care what the projects were. But to give you kind of a flavour of the things that I have worked on, because I'm guessing that's really what you want to hear about, is so when I first started the Institute, I was working on cochlear implants, trying to understand how the brain responds to going deaf and then receiving a cochlear implant. So it rewires itself quite dramatically. I then did some work on bionic eye stimulation. So I naively thought it's pretty simple. You just move the stimulator around from the ear to the eye and all the rest will be pretty simple. It turns out a little bit harder than that. But it was it was very exciting to see our first patients have bionic eye implants in and see them see for the first time. Been involved in some, perhaps some of the most exciting ones is that I actually find is when we have some of our young researchers have their first success in the lab. So we've run experiments where we're trying to use optogenetic stimulation to stop nerves responding, so basically inhibit nerve activity. Seeing some of our young researchers do that work and get their first positive result and not be confident enough to believe it and want that reassurance that, no, that's actually an amazing result. That's the first time we've ever seen that in the world that anyone knows of. That's actually some of the really exciting things, I think.
That's a really interesting perspective. I mean, I remember the first experiment that was successful that I ever did. I almost was in disbelief because it didn't feel real. I'd say 90% of all the experiments I've ever done have probably failed miserably. But I suppose at the same time, guide information for what to do in the future.
Yeah, and I mean, the other thing I always find really interesting and amazing to watch is young researchers come in who have predominantly only done kind of undergraduate lab-based experiments, which work. Like if the experiment doesn't work as an undergraduate, you mucked it up. Like there's no ifs or buts about that. The first time they come in and do a real experiment where we don't actually know the answer, and they say, oh, it didn't work. And we go, well, what did I do wrong? And it's like, well, who knows? Maybe you did everything right and our hypothesis is wrong. And they just give this really quizzical look like, what do you mean? It's like, well, no one's done this before, otherwise we're not doing this.
Yeah, of course.
The other one I like to talk about is we had a young researcher one time and we're combining electrical stimulation and acoustic stimulation into the one ear to look how the brain responds to that, because that's often what happens with cochlear implants nowadays. And so we've done these electrical recordings, these acoustic recordings, and then she said, oh, can we combine them? And I went, no. And she said, oh, why not? I'm like, why isn't there a button that is, play both stimuli? It's like, because we make those buttons that deliver those stimuli. Yeah. We haven't made that button yet. She said, oh, don't other people do that? And it was like, if other people do that, then we're not doing this experiment because they've already done it.
Yeah.
So the fact that everything is kind of being built just before it's required in the lab is also, I think, one of those really exciting things for me. Our equipment often breaks, 2 days after we finish using it, because we've moved on to the next thing. It doesn't need to last a lifetime when we're in the lab. Obviously, anything going in a person needs to last a fair bit longer.
Yeah, absolutely.
Interesting. I'm really curious also about the technology behind some of these. I think some of our viewers would be interested to know what goes into a cochlear implant. How does it work? And maybe you could give like a 5-year-old or a 10-year-old explanation for that tech.
Yep. So cochlear implant has two main components, an external component and an internal component. The external component just sits behind your ear. It's got a microphone, a speech processor, a battery and a transmission coil. That's pretty much it. It's got a lot less processing power than what's sitting in all our pockets at the moment in terms of our mobile phones. It's actually not that clever. And really all it does is it breaks up the sound to different kind of frequency ranges and then sends that information through the coil to the implanted device. And its job really is to kind of break that sound up into those different frequencies. We often describe it as, breaking the sound up to decide what key on the piano you're going to press. The internal component receives that information, also receives power that's transmitted wirelessly across the skin, and then there's a stimulator chip in there that produces electrical stimulation that goes down wires that then go into your ear and stimulate different spots along the cochlea. The reason the cochlear implant works is that the cochlea is tonotopically organised, which means that the base of the cochlea responds to high frequencies and the apex of the top of the cochlea low frequencies. So if you stimulate the right spot, you hear a high-pitched sound or a low-pitched sound. And that's the reason cochlear implants work. So you break the sound up and you stimulate the right bit of the cochlea. Okay. It's as simple as that and as complex as that. To be honest, though, you can go online and listen to kind of cochlear implant simulators, and they sound rubbish. We've got lots that you can listen to. The first time I ever heard what we think cochlear implants really sound like, I couldn't understand a thing that was going on. But now when I listen to them, I can understand perfectly. So they present information, but it's not like normal hearing, not even close. But they present enough information that you can understand speech, particularly in quiet. So in a conversation like this with a cochlear implant, happy days. Most people will do really, really well. You probably wouldn't even notice they've got one. Take them out to the pub, not a hope.
Sure.
Take them out in the wind, not a hope. Try and listen to music, not very good at all.
That's fascinating.
Tonal languages, not very good at all either. So they're the kind of frontiers in terms of how do we get those information and how do we make it easier to listen. So that's one of the really things we think about a lot now as well, is that currently people can do well, but they spend a lot of mental energy thinking about what they're hearing and understanding it, whereas you and I mostly do that without even thinking about it. So cochlear implant listeners often report being really tired at the end of the day from listening really hard all day.
It's an additional task, I suppose. So what was the Bionics Institute's involvement with the creation of that?
So Graham Clark founded the Bionics Institute. So about 30 years ago, Graham Clark was working at the Department of Otolaryngology at the University of Melbourne, based in the Eye Hospital, and founded the Bionics Institute. So Bionics Institute was involved in the very early safety studies. Graham Clark was there and did the first cochlear implant at the Victorian Eye Hospital. At that stage, there was the Department of Otolaryngology, University of Melbourne, Bionics Institute, and a hearing CRC. So it's a commercial entity to help kind of drive that kind of research. And those three arms were set up partly because they allow access to different funding streams. So, university is really good for government grants, CRC is really good for industry money, and not-for-profit medical research institutes are really good for philanthropy money. So having those three entities working really close together is the best of all worlds. And so that worked really well. Well, Graham was in charge of everything, and then obviously over the years we've grown our separate ways.
Fascinating. Yeah, I think the tech also was just really interesting because you're not actually creating a new cochlea, right?
No,
you're just inserting wires into the positions in the cochlea that would correspond to the right frequency, and that's fascinating. That's right?
Yeah, that's correct.
Okay.
So if and so that's one of some of my early work's looking at the fact that the cochlea normally has this, we often talk about as tonotopic organisation, toned as in frequencies. Not quite sure it's actually the fact is that the rest of your brain has this cochleotopic organisation whereby the bit of your brain that normally responds to low frequencies is not quite, but almost hardwired to the top of your cochlea. One of the things about cochlear implants, if you implant an individual who's born deaf and matures to about 8, 9, 10 years of age, they actually do really poorly. If they've gone deaf after the onset of speech, normally, they do quite well. If you implant them before the onset of speech, they'll do quite well. But if they're deaf over that really critical period, they often do quite poorly. And one of the things we found was it's because the brain needs the input from the cochlea during that really critical period to do that wiring. And if you miss that opportunity to do that wiring up, it doesn't matter now that you're stimulating where it should be high frequency sounds, you might be hearing low frequency sounds or a mix of sounds. And so if you don't get that kind of wiring done really well early, cochlear implants don't work very well.
Wow. So maybe we can contrast that technology of the cochlear implant with the bionic eye. Tell us a little bit about the bionic eye and how that works.
Yeah, so bionic eye, we put an array of electrodes into your eye. One of the philosophies that came out of the development of the cochlear implant was safety is paramount. So one of the things about the cochlear implant is we put this electrode array into the cochlea, which is a bony spiral, and it's actually a very long way relatively from the nerves we're trying to stimulate. So we actually don't get the best resolution we could, but it's really, really safe. We're not near the neural things we're trying to stimulate. So when we started to have a look at how to develop a bionic eye, we looked at the eye and went with our collaborators at the Centre for Eye Research Australia and University of Melbourne and University of New South Wales, where should we put our electrodes to stimulate? There's other groups around the world who are putting electrodes right into the retina where the things you think you want to stimulate are, and you can get really high resolution because you can get lots of electrodes in there. But the surgery is epic. Like it's 8 hours worth of surgery and it's just crazy. There's like 4 people in the world who can do those kind of surgeries. So even if you've got a really good device, translatability becomes pretty difficult because if there's only like 8 people in the world who can do the surgery, you're not treating very many people. And also, because you put your electrode right next to things you want to stimulate, it's really easy to damage them and not be able to stimulate them anymore. So we actually chose to do in the suprachoroidal space is what it's called. So if you think about the eye, there's the sclera, the white bit around the outside of your eye, and then there's layers within that. That sclera is like, we often describe it as like the leather around your football, and there's a bladder inside, which is the vitreous. And so if you go between those 2 layers, there's like a natural pocket you can go into. So that's where we put our electrode array. So we're actually quite a long way away from the retinal cells that we want to activate, in kind of a safe pocket, and we can stimulate from there pretty happily. And so we put this array of electrodes in there and we start stimulating. And then obviously the question is, well, when you stimulate, what do you see? How should you stimulate? How fast? What kind of pulse sizes and shapes should you use? So we did a lot of preclinical work to try and get a handle on what the electrode should look like. And then we tooled up for our first in-human trial. And at that point, because we weren't confident enough about exactly what stimulation we were going to require, we chose to use what's called a percutaneous plug. So these individuals actually had essentially a plug coming out the side of the head for 18 months where you'd plug in a stimulator into to be able to stimulate on those electrodes. Because that way you can do lots more things. If you fully implant a device, you're limited to whatever that device can do. But if you've got a plug, you can do almost anything you like.
So explain the plug again.
So it's quite literally
okay.
On the side of the head, they've got a titanium pedestal with 20 plus little connections in there. So think about like a really high density connector for a phone or a TV.
Yeah.
Basically one of those on the side of the head.
So then do the wires come out like on top of the skin? Or
no, and so from that plug they get tunnelled down with an electrode array and then into the eye.
It's like straight up cyberpunk.
but scalability is obviously
problematic.
Yeah.
So for all medical devices, wires and connectors are the bane of everyone's existence. So, people often talk about, Elon Musk's and his, Neuralink bazillion electrodes and all that. It's great, but you got to connect them to something.
Technology for billionaires.
Yeah, and so, and again, with the bionic eye, one of the great things about the cochlear implant, nothing moves. Like you put the stimulator package goes under the skin on the side of your head, you route the wire through in a bony cochlea, everything's completely static. The eye moves like a mad thing. Even when you think your eyes are still, they're not. There's microsaccades going on. Yeah. And so one of the things we spend a lot of time on is actually how do you get a wire out of there to this plug without it breaking over time, because that thing's fatiguing. As you know, you wobble a wire too many times, it breaks. So for a while there at the Institute, we had a cupboard full of plastic skulls with plastic eyeballs in them, just rotating back and forth with a lead wire attached to it. Durability testing. It was a great prop to show people who wanted to come around the Institute, but it was also actually doing really valuable work at the same time.
Fascinating. So I'm also curious about the positioning of these electrodes. You mentioned that they're just under the sclera, above the vitreous.
Outside of everything else. So in the suprachoroidal space, so under the sclera, the wrong side of the retinal cells in terms of, light normally goes in the front of the eye, goes through the transparent retinal ganglion cells, bipolar cells, photoreceptors. There's a pigmented epithelium often, and we're on the other side of that. So we are miles away from the retinal ganglion cells, which is our target. But it's a relatively safe place to be. And the other thing was it's a relatively easy surgical accessibility. I say easy because I never had to do it. But basically, if you just put a slit in the sclera, you can just slide the array around the outside of part, but inside the other part of the eyeball and into place.
Yeah. But I'm curious about, so what actually ends up being stimulated? Because if you're so far away from the retinal ganglion cells and you're closer to the bipolar and the horizontal cells, are we stimulating the horizontal and the bipolar cells, or is the electrical signal traveling through the vitreous and all the way to the back of the eye?
So we're already at the back of the eye.
Okay.
So we often implant we aim to be under the macula. So we're already back there.
Oh, that makes sense.
But in terms of what we stimulate, everything is the short answer. Again, in the cochlea, there's only really excitable cells. Spiral ganglion neuron, you stimulate it, you hear it. There's no, we're in the retina, on and off. The off is the bane of existence for retinal prostheses, because when we stimulate the on pathway, so you see light, and we stimulate the off pathway, so you see opposite of light. But we stimulate them both. So when we stimulate, really what you perceive is the slight mismatch between those two. And we certainly probably activate parts of that bipolar and amacrine network as well. But who knows what state that network is in, because we only implant individuals who've been blind for quite some time. So we also know that that whole state is degenerated by that point. So how much of that network is even there still, we don't know. We know there's an awful lot of remodelling that occurs. And so it's a bit of a mess. It's not like what you're going to see in the textbooks in terms of a beautiful organisation. And that's part of the difficulty of retinal implants, is that it's nowhere near as clean as a cochlear implant because of the complexity of the retina.
Interesting. So we've spoken about the cochlear implant, the bionic eye. What other technologies that are innovative are you currently working on?
So one of the ones I'm personally most excited about is we call it eavesdropping on the nervous system. This came out of a collaboration with Janet Keast over here at the University of Melbourne. We were doing some work where she wanted to stimulate the pelvic nerves to look at where they went and innervation in the bladder and things like that. So came to us and said, I need someone who can stimulate pelvic nerves. Can you design something and do something for us? We go, sure, we could do that. So we did that. And we had these rats that therefore had these electrode arrays implanted on the pelvic nerve for a few weeks at a time, and we'd stimulate them for half an hour a day, because that's what Janet needed. That seemed like a really boring thing to do from my perspective. I mean, it was useful science, and Janet was doing great work. But while we were there, it's like, well, what else can we do with these electrodes? We've gone, that nerve also carries all the information about the bladder in terms of fullness, all those kind of things. I wonder if we could record from it. And tell bladder state. Now, obviously, people have known for a long time, what people often do is in an acute experiment, they'll basically pull that nerve apart and record from it, and it's carrying all the right signals. Not a very translatable kind of tactic, though, is to have to pull the nerve apart to record what's going on. People have also put electrodes in like the spinal cord or the dorsal roots and can do the same kind of thing, but again with very invasive technology. As I mentioned, at the Institute, we've got a real focus on translatability, and therefore we try to only make electrodes that have a clinical translational pathway, which means kind of minimally invasive. Now, to me, our electrode was minimally invasive because it just kind of sat on the nerve. To Janet's mind, it was pretty invasive because we were cutting up an animal and putting it on the nerve. So minimally invasive is a different term for different people. But so we had kind of like the world's worst recording conditions because our electrodes are just sitting outside the nerve, but we know they're on the nerve because we can stimulate the nerve and make the rat pee almost on command because that's, when we activate the efferents. And so we started doing this recording technique to see if we could extract out a usable signal. And lo and behold, we could. And so we called it eavesdropping on the nervous system because we're not actually kind of cutting any of the wires. We're just kind of listening in on the conversations on close by. And so that kind of technology has applicability in a range of places. So it works really well on the pelvic nerve. We're currently using on the sciatic nerve to kind of listen in on what's going on down there. And people go, well, there's lots of ways to record activity in nerve like that. What are you playing at? One of the things we can do is we can tell you what type of nerve is firing. So we can tell you if it's a afferent or an efferent. We can tell you if it's a fast fibre or a slow fibre. And in particular, we can extract slow fibre afferent activity from the sciatic nerve in kind of just rats that are just kind of wandering around doing, going about daily life activities, which means we can probably do the same thing in people. And so we can extract those signals that sense pain, those signals that sense inflammation, all those kind of things that are really important, which are much, much smaller and normally much, much harder to see than those big signals about your body moving and those kind of things.
You know what this reminds me of? It's like in Sims when you have the status bars.
Yeah.
And it's like, I need to pee. And you can see the other people as well. It shows up in your VR glass.
Yeah, so it's very much, and so the obvious question is, well, that's cool, James, and really nice technology, but
what's the utility?
What's the utility? And so when you start thinking about people who have either had strokes or some paralysis of some description, spinal cord injury patients, we're not going to try and tell them where their legs are in space, but if we can tell you, is your leg sitting somewhere that's hot and is about to burn? All those bits are still running quite well in the periphery, but you have no sensation of them. So actually, if you could actually let the body do what it's good at in terms of signalling those messages about get this limb out of this space, great. We can sit on the nerve, we can listen. And you know what? We're on the right nerve to also stimulate and cause a withdrawal reflex. So you could think about it like a closed loop kind of device to do that kind of activity. And you don't need to have any conscious percept of it necessarily. It's those kind of things where we start to go, they're the kind of spaces where you can make a real impact on people's lives. I've spent a bit of time doing work on spinal cord research, and the big ticket items people always talk about are walking again. And if you actually talk to a lot of spinal cord patients, they go, it's not those kind of things. It's it's poo, it's wee, it's not burning myself. Yeah. They're the things that I care about because they're the things that really impact my life. It should be great to walk again, but I'd much rather not to have a carer, find me having soiled myself.
Yeah.
To know in advance. So it's those kind of things that can make a huge impact with the right technologies.
Interesting. Let's take a little bit of a dive back in history when you were a bit younger. Where did you train as a researcher?
So I was the kind of classic at high school. I was the classic kind of double maths, phys, chem kind of boy. Got to the end of high school and went, I've got no idea what I want to do. Yeah. So I thought I could do med, and I said, I don't think I like kind of sick people. I don't want to be in that space. I thought about arts. I went, I don't do arts. And so it was like, I guess that's science or engineering or law are the kind of remaining options. And Monash was offering a science eng double degree, so I went, that gets me 2 out of 3. I might as well go have a crack at that one. So I wandered out there, enrolled in that degree. The engineering year was a common year, first year, so I did all the engineerings. And they recommended you do computer science and physics as your sciences, so okay. Enrolled in that. Got to near the end of that first year, and one of my professors said, have you thought about doing biomedical engineering, James? I'm going, that would be what exactly? He said, basically you do electrical engineering and you do physiology as a science. It's like, that seems like a pretty cool thing. And also I looked around the electrical engineering enrollees, and it was, at that point in particular, 98% male. Looked at the physiology. It was much better odds, I thought, in terms of, I've got a good face for a podcast. So I thought I had a much better chance. And it sounded like it'd be interesting. So I enrolled in this biomedical thingy. was quite enjoying that. Got to the start of my final year when I was going to start my final year project. And the same professor came and said, "Oh, have you thought about doing a PhD, James?" And I said, "A PhD what?" I haven't got no idea. What are you talking about? And he said, "If you just sign on this form, you can come back for 3 years and we'll pay you to come back." Turns out it was a PhD scholarship application form. That was how naive I was. I didn't even know that's what I was doing. So I did that, rocked up for the first day of my PhD. I said, "What am I doing?" He looked around the room, saw like a data acquisition card and said, "Why don't you see if you can record some ECG or something with that thing?" It's like, "Oh, okay." Yeah. And so that was the start of my PhD.
Interesting.
It turned into, our lab did a lot of muscle physiology. So I was doing lots of recordings from muscle spindles and Golgi tendon organs that kind of give you that sense of proprioception. And then at one point I stumbled across this article that was talking about stochastic resonance, which is a theory that helps explain the roughly 100,000 year cycles of ice ages and non-ice ages that we have. So I did a whole bunch of stuff looking for that in kind of biological systems, and lo and behold I did. So I did some modelling, I did some electrical engineering designs and stimulators and amplifiers, did some physiology, and I thought, I came to the end of my PhD and went, I should probably actually try and get a real job now. So I applied for a whole bunch of jobs, didn't even get an interview. Not a single interview. So after 9 years at uni, I worked out I was overly qualified and not overly employable in the real world.
Welcome to research.
Welcome to research. So I spoke to a friend who had just turned down a postdoc in Sydney where that postdoc was still open, and it was. So I got an introduction, met the head of that lab at a conference and said, I hear there's a postdoc position available. He said, yeah, there might be. He said, if you buy me a beer, you can have it. So I bought him a beer, and so that's how I got my first postdoc position.
That's a kind of solid way to get introduced.
In the meantime, before I started that position, my partner was finishing off her PhD at Uni Melb, and was adamant she just had a couple of months left to go. So I was looking for something part-time to keep me in Melbourne for a little while. So I got a position at the INE hospital in the Department of Otolaryngology, doing some data analysis. And loved it, really enjoyed it. But I'd already committed this postdoc in Sydney, so I left for that. Took my partner just a smidge longer than that, couple of months to finish her PhD, like a year and a bit more. And in fact, the day she arrived in Sydney, I got a call from my to-be boss in Melbourne saying, I'm applying for a new grant, I'd really like you to be on it. Are you interested? And I said, my partner's just arrived in Sydney. I probably should check before I commit. And she was like, sure, I don't know anyone here. I've got no ties. Fine. And so I went on the grant. We ended up getting the grant. So I came back to Melbourne, and that was 20 years ago when I started my current role.
Very interesting narrative, I think.
Fascinating. Yeah, I'm struck by the laissez-faire attitude of just,
I don't know what's happening.
This.
I'm going to sign this.
Sign this, you can do a PhD, buy me a beer, you can be my postdoc. I feel like times have changed dramatically on that front.
These days it's like transcript, interview, second interview, third interview, background check,
declined.
Police check, declined.
Yeah, look, so it's certainly a bit more rigor now than there was, but I think the essence is still there, which was the whole. So I signed the professor I did my PhD with had known me for the last 4 years, so that background check had been well and truly done by that point. The guy who I did my first postdoc with, he knew the head of my lab that I did my PhD in. He knew the kind of stuff I did. He really wanted the skill set I was bringing. So we drank the beer together and might have had a few more after that. So I presume that was actually probably the interview process being done there. But to be honest, when I look to employ new people or get new students, fit is incredible, important. I mean, I always talk about whatever you've learned, I don't really care. We'll train you in what you need to do, because you know what? No one knows how to do what we do, because we don't even know how to do what we do yet. You will learn it as we learn it. So whatever skills you're bringing, great, but you're going to have to learn new skills anyway. So when I'm looking to fill positions, it really is, are you someone I'm going to have fun working with? Because if not, I don't care what skill you bring. I don't want to play. Life's too short. I've shared my office up until recently with the same person for 10 years. I spend more time with him than I spent with my partner over that 10-year period. So if I didn't get along well with him, forget
Torture.
it. Torture. I would have left by now.
Yeah.
I mean, to me, that's actually the cool thing about work is making sure you're enjoying what you're doing, because we were talking before about how competitive kind of research can be. It is, and therefore you've got to have fun while you're doing it, because you never know when that journey might end, so you might as well have fun on the way through. And if you are and it ends, so be it. But if you've had fun along the way, what more can you want?
Absolutely. I think the pressure of the industry gets to some people, and they reflect their behaviour on their students. Have you ever seen, witnessed, experienced anything like that?
Oh yeah, I've seen plenty of times where more junior people get absolutely bawled out by the more senior people for no other reason than that senior person has just got probably a whole bunch of bad news. But also being a senior person now, I hope I've never done it. I don't think I've ever done it, but you can easily see what happens, because the thing I worry about the most is not me, is the people who are dependent on me for their jobs. So the day you have your first in-person reporting to you was the scariest day of my life, because all of a sudden, I was always like, oh, if I stuff up, I'm out of a job. So what? That was my bad. It's on me. Yeah. The only person who suffers is me. If I stuff up and you lose your job because I stuffed up, and you're going to lose your job before I do because you're the junior person who's more expendable, I'm terrified of that. I know people who refuse to become lab heads because they can't stomach the pressure that comes with being responsible for, or the feeling that they're responsible for someone else's life. Now, often that's not true, and often the junior people don't actually care because they know it's on them as well. Yeah. But certainly as a manager, you can sometimes, and heads of labs, you can often have that feeling of it's all on you. So if you have a bad day and you think things aren't pear-shaped, it is really easy to lash out. We're all humans. And so I've certainly seen it happen. The junior person comes with a result you don't want to see. Or more like the junior person kind of mucked up an experiment. Yeah. They broke something expensive. It happens. One of the things we often do in the lab is, so we do all this cochlear implant work. As part of the process, we almost always extract the cochlears at the end of an experiment to look at the histology to see exactly what's going on. It's a pretty delicate process to do, and it's pretty easy to crack them and therefore kind of render them almost useless. So we often talk about you get one for free. So the first time somebody cracks a cochlea, it's like, don't worry about it. We've all done one. No dramas. It's okay. Just don't do it again. So you get one for free because we're all going to do one. And it takes some of that pressure off, and they realise that you've done it too. And I mean, the other thing I'm really big on is when I muck something up, and particularly if it's expensive muck up, I completely own it. Because it's on me. Of course. So people understand that we all make mistakes. We all do things that not necessarily have the best outcome, but provided it's done with good intent, that's life. We move on.
So I suppose the question is, what happens when you break the second one?
When you break the second one?
Execution.
Oh, so that's when we go, so what went wrong? So, obviously you broke the first one, there was something wrong with your technique. Hopefully you've learnt from that. If you didn't learn from it, is there more training we need to do? Is this actually just not your jam? Are you not a hands person? Are you or were you just not paying attention? And depending on which of those is the answer, then we have different conversations. Well, I've never fired anyone for breaking too many cochlears, because normally people go, I'm just not very good at this. I don't want to do this anymore. Get them into a role that they're good at and enjoy. Because that's the thing, if they don't like doing it, they're more likely to bust them. So don't get them to do it.
Sure. I think it reminds me of a time that I left antibodies out for too long. And then I couldn't admit to it because they were really expensive, so I just put them back in the fridge.
So
eventually I said something, but
I was going to say that they're only finding out right now.
And I reckon that's the one. It's that nobody would have cared if you left them out. Yeah. That you put them back. That as a head of
getting more trouble now.
That's the thing that would give me the heebie-jeebies, because what other experiments did we just destroy?
Exactly.
And it's always the cover-up is worse than the crime.
Exactly.
Of course.
So admit what you've done.
I do think it comes back to the mentorship and the guidance from the supervision.
The culture.
The culture of the lab. I've been in labs where you can't say something wrong or they'll cut your throat. Right?
Yeah, which I hate, is the antithesis of the culture that I strive for. I have found it interesting. So Rob Shepherd was the director of the Institute for a long time and my boss for 15 years. Very much like that fatherly figure kind of mentorship kind of thing. So everything was very gentle and lovely. Robert Klupak's the CEO, far more business-like. First kind of times we talked hard science, like I felt like I was having, things torn off me and kind of came back going, maybe I'm in the wrong career. Just a completely different style though. He's like it's a very pushing hard to find what line you will hold in terms of being able to defend your science. And from his perspective, it's all about, I can't send you out in the world to talk about your science if you don't defend your science.
Absolutely.
And so the balance is having that tough questioning that's not personalised. The other thing is that, of all the groups I work with in terms of the science I do at an institute, I don't run any of those groups. Other people run those groups. So either people who have come up through, who had my junior postdocs who are now senior enough to run their own groups, and I sit in there and I, hopefully contribute usefully. But that's the other thing we do is we make it really clear that just because I'm one of the oldest people hanging out in that room now doesn't mean I know best, and there are people who are going to know a lot more than I do. Yeah. I'm always the first to admit that, I actually don't know very much. I know lots of people who know lots of really good things, and I know who to ask, but I don't actually often have the answers. So I don't pretend I do. And if you don't know, say you don't know.
Absolutely. I suppose it comes back to honesty, integrity, maybe even ego. What's your perspective of the ego of some people in the industry?
Oh, huge. There are players who have massive egos. And again, it comes down to the kind of the current system incentivizes the blow your trumpet. Mine is the best research ever. I'm doing this groundbreaking work. It's all me. Yeah. We all know it's never me. It's us. And often what I've done is not that interesting. Someone else has done something probably just as interesting. But their current kind of incentives around funding can kind of drive that. If you focus purely on the peer-reviewed grant system, which is, again, why I really like being at somewhere like the Institute, where with a translational focus, trying to do a bit more of the spin-out work, those kind of things, there's slightly less emphasis on that and more on if you do good work and you have a good IP position and there's a clear clinical need, someone's going to pay for it anyway. So take some of the emphasis on the individual doing the work and more on the outcome of the work. And are you actually going to hit that end goal? And is it a real end goal as well? Is the other big thing. I have very little ego. I mean, I wear shorts to work every day. My boss knows he can ask me to wear pants like 3 or 4 times a year, no more. I'll put a collar on if I absolutely have to as well. But it's just not what I enjoy doing. Yeah, I'll tell him I wear a suit for an extra $0 on my paycheck, at the right end, obviously. But otherwise, not interested, because it's not who I am. So the word I often talk about is authenticity. Yeah. Know who you are and just be authentic to that. And if that's someone who's got a massive ego and loves to spruik themselves, great, you do you. It's not me. I'm the guy who's going to kind of hang out with the peeps in the corner, have fun, do good work, spend half an hour in the tea room doing the crossword if that's what I feel like doing that day with everyone, because that's great. A really level playing field I really like, because you never know where the next great idea is coming from, and it's probably not me because I probably had mine. Someone else is going to probably have a much better one.
Absolutely. It must have been we would have dressed down if you gave us notice.
Yeah, Ben and I had a conversation. We're like, maybe we should we wear the blazers every time? I don't know. Maybe we want to look professional.
Yeah. So I've got a suit hanging on the back of my door at work for the emergency suit. I talk about it as. So I will get a heads up if I have to madly dash and get changed to put that on, so I can impress some high net worth individual. But it's also interesting the shorts can actually be remarkably disarming, because people all of a sudden go, oh,
he's just a guy.
He's just a guy. The other thing I've discovered, it was never intentional, it's actually pretty good for recognition. So most people go, oh, was that the guy in the shorts you're talking about? It's like, yep, that's the one. Whereas like, oh, it's the other middle-aged grey-haired guy in a blue suit. There's a lot of them around. There's not many of us grey-haired middle-aged men in shorts. So,
absolutely. Yeah, I'm curious. I'd like to switch back to one of the problems that you've been working on at the Bionics Institute. It's on Crohn's disease. Mm-hmm. Can you tell us a little bit about Crohn's disease and what you've been working on in relation to that?
Yep. So I guess I talk more about inflammatory bowel disease than just Crohn's disease. So I'd never heard of any of them until it's probably about 7 or 8 years ago now. It was one summer I got a call from Rob Shepherd, my boss, saying we're putting together a grant to do vagus nerve stimulation for IBD. It's like, cool. I know some of those acronyms, but not all of them. What exactly are we doing again? And what had happened was that DARPA, so the Defence Advanced Research Projects Agency, those people who brought you the internet and smart bombs, only work on DARPA hard problems. If it's an easy problem, they're not interested. They only work on problems that are really hard. One of their really hard problems is a whole bunch of their warfighters return, particularly from the Middle East and Afghanistan, with PTSD and Crohn's disease and inflammatory bowel disease. This is where basically the body is attacking itself, causing their bowel to be inflamed, meaning that in worst case their bowels rupture, potentially in death. They're particularly interested because there's a higher than average prevalence of that in their return service people, and these people are having this in their early to mid-20s, and it's a lifelong condition. There's a bunch of biologics you can take for it and anti-inflammatories. Most of them eventually don't work, and so a large proportion of people end up having to have a chunk of their bowel chopped out that's so badly inflamed. And you can do that once, you can do that twice, but after the third, fourth, fifth time, you run out of bowel. So, so if this happened to an 80-year-old, you'd go, you know what, probably just cut the bowel out and move on because something else will probably get them eventually. In a 20-year-old, it's devastating. And so DARPA were on the hunt for solutions. Some other people had looked at using vagus nerve stimulation, so the nerve that innervates all your viscera, the superhighway between the brain and your bowels and your guts and all those kind of things, to try and see if it would help. So vagus nerve stimulation has been approved for many years now for treating epilepsy. People stimulate the vagus nerve in the neck, cervical level stimulation, and it seemed to have a reasonable effect on IBD and Crohn's, but with a few off-target effects. So at the level of the neck, that vagus nerve innervates the heart, the lungs, and a whole bunch of other things. And so what I found completely bizarre was that people using these devices, which are designed for epilepsy, and setting the level of stimulation by implanting this device around this nerve, which is not too difficult, turning up the stimulations until you start to cough or go hoarse in the voice, and then turning it down a little bit. That's how you set the stimulation level. Got nothing to do with the nerve you're trying to stimulate. It's basically got to do with, am I making you have some off-target effect? And in people where they did that, it seemed to have a pretty good, reasonable kind of efficacy. But we looked at it and went, that's just craziness. Why are you setting levels off targets? If you stimulate the other vagus, so people who stimulate it much stronger influence on the heart, and you can stop people breathing, you can stop people's hearts if you try hard enough. It's like that just seems like madness because stopping breathing is a pretty bad off-target effect to treat your Crohn's disease. So we, with collaborators at the Howard Florey Institute and University of Melbourne, went, well, we know a little bit about anatomy, and we know that branches to the heart and lung come off pretty high. So if you look at the nerve below the diaphragm, all those branches are gone. So you can stimulate as hard as you like, and you can't affect the heart or lungs because those branches aren't in that nerve anymore. So that seems like a pretty sensible thing to try. So that was great. And so we stimulated there and showed that we had a pretty good effect on this inflammation. But then we'd created a problem for ourselves, which was we have no idea that we're actually stimulating the nerve because there's no way to tell immediately whether that stimulation is having an effect whatsoever. And so we believe that's why many people hadn't kind of tackled that location before. But from being in the cochlear implant world for a long time, we've stimulated and recorded from the same electrodes. So we can stimulate the nerve, record from a different electrode just a bit further up, and see the activity we've just produced propagate away. So we just use that exact same technology on the vagus nerve, and it worked a charm. So we showed it worked in some rats. We then scaled it up to kind of a sheep size, showed that it was safe to do. And then we had the issue of, we want to go to humans, do a first in human clinical trial. Oops, we don't have our arrays just kind of made in our labs. It's great for kind of putting in sheep and stuff, but we can't put that in people. Looked around Australia for who could make such a thing, and the answer is no one really. Cochlear have the facilities too. Cochlear were not interested in making something like that for us. It's just noise for them. So we ended up going to a company in the States $1 million, and 18 months later, we get our arrays back, looking pretty much like what we had designed to start with, but now available to put into people. And unfortunately, that 18-month delay meant we got our arrays available for us right at the start of 2020. COVID, blah, blah, blah. And so just recently, we've been able to implant our first patient with this device. One of the other things we did along the way, was like, let's not ever be stuck in that kind of situation again. So the Bionics Institute with the University of Melbourne spun up what's known as Neuromodulation, which is a for-profit company making devices. And so if this was to happen again now, we would go to them, get that done much quicker, much faster, and get that first in human trial running sooner. Because the big question is, we believe it's going to work, but there's still a decent chance it's not going to work. So the quicker we can find out it's not going to work, the better. So one of the things I'm really passionate about is doing experiments where we're happy to say, this is no longer interesting or useful for us to do, stop. Because there's more things than we can ever do that are interesting out there. So it's not about, is this one a cool one to do? It's about, when should I stop doing this one and do something else because this one is no good to do anymore? So that's what I'm really want to do is, fail things quickly and move on to the next bazillion interesting things that are out there.
Interesting. I was actually going to bring up the topic of innovation and research in Australia and how it compares to places like the US. What's your perspective on how funding and accessibility of technology, or let's say development institutes, affect the progress of Australian research compared to overseas?
So if you think about that narrative I just gave you for that vagus nerve stimulation device, Australia is fantastic at that, doing that rat study, doing a bit of that sheep work, and then we fail dismally on quite often because we don't have the right infrastructure, we don't have the right mindset, and we don't have the capital available, really. We got from first idea to ready for first in human trial on about $5 million in would have been 5 years if you exclude the COVID break. That's cheaper and faster than you could do in the States. But it's still, for us, it's very difficult to do those next steps because the next steps are really expensive steps. You need stimulators, you need clinical trials, you need those kind of things, and they cost a lot of money. And there's just not the appetite to fund that kind of work in Australia as I think there should be. I think it's slowly changing. I think we realise that's a spot we need to play in because it's a bit like, digging up rocks, selling them overseas and then coming back and buying cars. The more value we can add to that product before it leaves our shores, the better. Yeah. We should be doing more of that here. We've got a perfect culture to do it. We have genetic diversity available on hand. We have a really good, universal healthcare system. So all the things are in place for us to be able to really excel at those early stage clinical trials. Yeah. We've got the advantage of our regulatory situation a little bit different to many other countries do. Those first in human clinical trials approvals are done at the local ethics committees rather than the FDA, which would be in the States. So it should be faster and quicker to run those trials, and it typically is. And so it's a really good way, as I said, not to prove that the thing's going to work and do your reimbursement studies, but to prove it's not going to work so I can move on to the next problem.
Sure.
So to me, that's what we should be doing more of, but also be willing to know it's not going to work. I mean, as I said, to me, that's what I'm really kind of passionate about is doing studies that show it doesn't work so I can move on with my life, which no one wants to do. No one wants to know their baby's not the right one. No one wants to know the idea of spending the last 3 or 4 years on is not going to work. It's tough, and our funding mechanisms and schemes don't encourage it. Our funding scheme encourages to write a paper on it and say, here's the next version of it I should try, rather than, this one's done, let's go and do a new idea.
Yeah. Almost a perpetual cycle of research papers without translation.
Yeah, again, so one of the examples I often give is back to the Bionic Eye.
Yeah.
So the Bionic Eye was on $50 million-ish from the federal government, big consortium. I found one of the things I found really interesting is the different motivators of the different people involved in that project. So, as I said, there's a large consortium. So we, Centre for Eye Research Australia and University of Melbourne, we were kind of hell bent on getting something into people. I mean, from our perspective, that project was led really heavily by Chris Williams, who was just like, and Penny. from Sierra, they were just hell-bent on getting something into people to see whether it would work or not. That was their primary focus. Obviously safe and all those kind of things, but primary aim is to get something into a person isn't going to help. There are other people who wanted to do research, and it was great research. Great research was done, lots of students were trained, and for them that was a great outcome. It was ARC funded, and part of ARC's mission is that training. So from an ARC perspective, having some more papers and having some training done is just as useful an outcome as helping someone. And so there is neither is right or wrong. They're just different kind of outcomes. And to me, I'm not that interested in basic research. I tell people, if you want to do basic research, let me help you get a position over here at the University of Melbourne. If you want to do translational research, come and work with us in the Institute. Neither's right or wrong. They're just different types of things, and doing the right one in the right spot is really important.
You've mentored a lot of students as well, and obviously research is competitive, as we've discussed. Well, what's some advice that you give them, and what are some habits and mindsets that you try and instill in them to prepare them for this world of, I guess, translational research?
So I often talk about research as it's almost like a calling. It's rarely ever the right career choice if money is your main motivator, particularly because we have a lot of engineering kind of background students come through. They will always earn more money doing something else. Our data analytics people, if they're with us, they're definitely missing a couple of zeros off their paycheck if they're out doing something else. So if that is your motivator, don't do research, full stop, end of story. Do research because you like the kind of thing you get to do when you do research. In my role, you asked me, you tried to get me to describe my average day, and I said, I don't have one. That's one of the things I love about research, is that I get to do more things in my week than I would if I was in industry. Because if I was in industry, I'd be pigeonholed in doing just probably one of those bits. And I wouldn't be allowed to do all the other ones because the focus is on getting money in the door, specialise, off you go. I really love the variety you get to do. So that's one of the things I always talk about students too, is particularly as a PhD student, stick your finger in every pie you can find. I mean, that's the way I've ended up doing what I do. Something vaguely interesting walks past my door as a project. Well, can I be involved? Can I go and play, please? Because that's fun for me. So I probably work on far more things than I should because they're really interesting. Is it detrimental to my career? Probably. Do I care? No, because I'm having a great time doing it. So that's the kind of philosophy I try to live. So rather than give advice to students, I just say, this is what I do. It's worked really well for me. I'm not going to guarantee it's going to work for you. But what I say is think about what you enjoy doing and just do as much of that as you can. Because life's too short. If you're not enjoying it, stop it. Just because you start your PhD doesn't mean you have to finish it. That's okay. Just because you finish your PhD doesn't mean you have to have a classic research career. Again, I mentioned earlier my partner who did a PhD in microbiology, discovered about 2 years in, didn't like research, hated experiments, took every experiment that didn't work personally. Discovered she loved writing. I don't understand that at all. But, she absolutely loves writing. And so she started a career as a medical writer, moved into governance, now does quality, where there's lots of words. She loves looking at words and putting them together, and I just go, they kill me now.
That's the worst part of research.
But she also discovered she loves being around scientists. She likes science people. And so she's made sure she stayed near the science people because she worked out she liked the words and she liked the type of people scientists are, didn't like doing the science herself. Interested in the science, just don't want to do it myself, thanks, was her philosophy. I like the people and I like having a dabble in the science. If someone else could do the words, that would be great, but I haven't worked out how to do that yet.
ChatGPT.
Is this the partner that you met at the physiology class?
No. I actually met this one in. We both played musical instruments, so we met in the orchestra at band camp.
Nice. Band camp. That's how all great stories start, right? Band camp. Easy. So, I want to ask a bit more of a personal question. How do you want to be remembered?
Ooh. So if I'm remembered at all, I'd be quite happy not to be remembered. I'd like to be remembered as just someone who actually really enjoyed doing interesting work. I have no desire to leave a legacy as the inventor of X. To me, the legacy will be a bunch of people out there doing really interesting things and enjoying doing it. Then I feel I will have contributed well to the world.
Humble.
Very humble. Yeah, I like it. All right. Well, let's switch now to what we call the quick fire round at Orange. Essentially, we've created a list of questions that we're going to present to you in quick succession. We want you to try and respond with the first thing that comes to your mind without filtering too much.
Right.
So the first question is, have you ever played a prank on someone? And if so, what was it?
Yes, wrapping everything on the desk in wrapping paper.
What was the occasion?
It was a birthday.
Awesome. That's a classic joke. Second question. What is your hidden talent?
My hidden talent. I've got a coaster that says I turn beer into water.
How so?
Well, that's what the coaster says. My kids gave it to me. Look, I'm quite good at a cryptic crossword. I'd say I'm not sure how hidden that is for people at work, but I'm not sure you'd pick that from what I do as my general life.
Interesting.
If you could choose one animal to be your battle companion, what animal would it be?
Wombat.
That's
Why?
good. That was very immediate.
He's like, damn, I've thought about this before. Wombat. Why?
So often it's because they're incredibly muscular. They can actually move at a pretty great rate of knots. They are you hit one of those with your car and you know about it. It's also especially good now because my daughter went away on a camp recently, was actually bitten by a wombat. So it's actually a fear factor for her now as well.
Is that? I didn't realise that's even possible.
So they were camping down at Wilson's Prom. She heard a rustle and thought her friend sleeping next to her in the tent was biting her finger, which I don't understand why she even thought that. Turns out the wombat had bitten its way into the tent and was biting her finger because apparently they can be attracted to like hand creams and stuff like that for some of the ingredients. So
that's fascinating. I thought they were always averse to humans and ran.
No, I think they were looking for food. So they're the Australian equivalent of the bear in that respect, I think.
It's been so many years since I even thought about the wombat.
Yeah.
You know it existed for a while.
All right, we'll move on to the next question. Do you have any bad habits you wish you could get rid of?
I'm lazy.
As a researcher, that's probably fairly conventional. Find the best way to do things, though.
Yeah, look, I talk about, laziness is the mother of invention, is what I think about it as. I won't, people often say, you're not lazy, you do blah, blah, blah. And it's like, yeah, but I minimise my effort on everything I do, which to my mind equals lazy.
Work smart.
If you could time travel only once, when and where would you go?
Ooh. I think it'd have to be forward in time, so I reckon it'd be somewhere in the future. Probably almost doesn't matter when you go. It's all going to be so unbelievably magical that it probably doesn't matter.
Or unbelievably dystopian.
I'll go glass half full.
That's good. Very good perspective. Speaking of laziness, if you could eliminate one chore from your life forever, what would it be?
Grant writing.
I love how you call it a chore. Yeah,
and look, I probably shouldn't have said that. Because I guess one of the things, if you talk to researchers, a lot of them will bemoan grant writing about we spend so much time, blah, blah, blah. Certainly one of the things I've been trying to do recently is change the narrative, thinking about it not as a chore to write a grant, but it's one of the few times you get to stop and think about what's any experiment I could do, what would it be? Because there's no bounds yet, because I don't have a budget I have to stick within because I'm coming up with a brand new experiment. So, but you told me to have no filter, so that's why I said grant.
No, that's good. We appreciate the honesty.
Let's do one last question.
Sure.
So, if you had to reflect on all the science that you've done in your life, what do you think has driven you? Because you said you're lazy. So, what motivates you to even get out of bed and do all this work that you do?
Is this a quick fire or am I allowed to give a longer answer?
Yeah, that's a longer answer.
So as I said, one of the things that it took me quite a while to realise what my motivator was, and it really is doing interesting things with people I really enjoy doing them with. So look, don't get me wrong. The postdoc I mentioned about buying someone a beer was doing microneurography. So that's where you stick a needle into an awake person's nerve and can record individual nerves firing. It's insane. The weirdest first 3 days ever of a job. I went up there, somebody stuck a needle in my arm and recorded from it. That was pretty cool because I'm going, that's my nerve. I can hear an individual nerve firing. Day 2, stick a needle in your own arm. That's when I had a lot of, what have I done wrong with my life? As I was holding the needle going, am I really about to stick this into my nerve? Day 3, stick it in someone else. So it was the classic see one, do one, teach one. But that visceral, oh my goodness, that's my nervous system responding. I can hear my nerves firing as you lightly touch my finger. I can feel that stimuli you're putting in my nerve, and it feels like you're touching my finger. Like that kind of visceral understanding of that's incredible. And of course, anytime you do something for the first time, and no one else in the world has ever done that thing, once you convince yourself it's actually really real, that's pretty exciting. But that's not the thing that gets me out of bed every day, because it happens so rarely. You'd be getting out of bed like once a decade. It really is that I get to go to work and work with people I really enjoy. I have a leave balance problem at the problem. I have way too much annual leave because I really like going to work. And so people go, why don't you just go on holidays? Like, well, because I like my job. Why can't I keep coming in and playing and enjoying what we do? And sure, there are bits I don't like. I don't like some bits and pieces, but overall, it's a really great thing to do. It's a privilege to be able to work there. I work on St Vincent's campus. I ride from Brunswick, so I ride through the parks on a lovely morning, spend the day working with cool people, doing things that perhaps haven't been done before, ride home through the parks again. And they pay me to do that. That's pretty amazing.
Awesome.
The little moments. James, thank you for coming on.
Pleasure.
It's been a blast.
Absolutely. Thanks so much.
If you like this studio, you like this podcast and the space that we're in, or if you're seeking a dynamic and collaborative environment to fuel your success, don't miss out on Melbourne Connect Co-working.
They are now offering an incredible 25% discount on 12-month memberships when you quote ambition in your inquiry. Follow the links in the description to learn more.